Hello, so I'll be discussing my assignment 1.2, which is high intensity and low intensity discharge lamps. For high intensity discharge lamps, HID or high intensity discharge light bulbs and lamps are a family of gas discharge arc lamps which create light by sending an electrical discharge between two electrodes and through a plasma or ionized gas. An additional gas is generally used, and this gas serves as an easy way to classify the major types of HID lamps, which is mercury, sodium and metal halide. These lamps are known for their high efficiency at turning electricity into light and their long rated life. HID lamps require a ballast in order to generate the initial surge of electricity needed to start them and to regulate their power during normal operation. In modern lighting usage, the HID lamp functions by sending an electric arc between two tungsten electrodes which are housed in an arc tube usually constructed of quartz. The tube is filled with an amalgam of gas and metal salts. An arc is created with an initial surge of electricity facilitated by the gas in the lamp. The arc then heats the metal salts and a plasma is created. This increases considerably the light produced by the arc, resulting in a source of light which is more efficient at creating visible light instead of heat than many traditional technologies such as incandescent or halogen lamps. Every HID lamp consists of an arc tube which is filled with gas. What type of gas is used depends on the type of HID lamp. For example, metal halide lamp can contain a starting gas such as argon, mercury, and metal salts, while a high pressure sodium lamp can contain a xenon gas, mercury, and sodium. Inside the arc tube are two main electrodes, mostly made from tungsten. The tube itself is usually made from quartz to withstand the excessive heat that develops while the lamp operates. Most bulbs have an outer glass to improve protection and efficiency of the bulb. There is also a ballast for each HID lamp that controls the current that pass to both electrodes. Ballast are required to start the lamp and ensure it operates correctly. Generally speaking, HID lamps are used primarily in applications where the most critical factor is creating as much visible light per watt as possible. Major applications include street lights, gymnasiums, warehouses, large retail facilities and stadiums, and plant growing rooms. Recently, these lamps have also been used in some high-end vehicle headlights. Since most HID lamps produce light which is either very cool white, blue, or warm white, yellow, they are generally not used in applications where the aesthetic quality of light is important. Also, some HID bulbs require an extended warm up time and are not suitable for applications where lights are turned on and off on a regular basis. For low intensity discharge lamps, oh no, low pressure lamps have working pressure much less than atmospheric pressure. They include low pressure sodium lamps, the most efficient gas discharge lamp type, producing up to 200 lumens per watt, but at the expense of every poor color rendering. The almost monochromatic yellow light is also acceptable for street lighting and similar applications. Low pressure sodium lamps also have long lifespan. Low intensity discharge lamps, or more commonly referred to as fluorescent lamps, are among the most widely used light sources in the world because they require little energy to produce a great deal of light. Fluorescents are a large family of light sources. There are three main types of fluorescent lamps: cold cathode, hot cathode, and electroluminescent. They all use phosphors excited by electrons to create light. Fluorescent lamps work by ionizing mercury vapor in a glass tube. This causes electrons in the gas to emit photons at UV frequencies. The UV light is converted into standard visible light using a phosphor coating on the inside of the tube. To get the lamp started, you need a spike of high voltage to get the arc started. The colder the lamp is, the higher voltage you need to get a start. The voltage forces current through the argon gas. Gas has a resistance. The colder the gas, the higher the resistance. Therefore, you need a higher voltage with colder temperatures. Since creating a high voltage is a challenge and dangerous, engineers figured out ways to preheat the lamp. That way, less of a high voltage is required. There are different ways to start a lamp, including preheat, instant start, rapid start, quick start, semi-resonant start, and program start. Low intensity discharge lamps consist of a glass tube filled with an inert gas, usually argon, at low pressure. On each side of the tube, you will find a tungsten electrode. The ballast regulates AC power to the electrodes. Older lamps use a starter to get the lamp going. Modern lamps use pulse start, which is done by components within the ballast. Common uses are lamps, both outdoor and indoor, backlight for LCD displays, decorative lighting, and signs, both high bay and small area general lighting, not used for lighting from afar due to diffuse nature of the light. And that's all. Thanks for listening.